So good afternoon. I'm Nijay Nirmala Devi. This is a short video on introduction to compiler design. So before knowing to know about compiler, we just want to know about a translator. A translator will normally convert source code into machine code, and here the translators are needed. And if we say that it is a source code, the source code might be written in any high-level language is called as the source code, and the machine code is the machine-level code in which the computers can understand. So that is called as the machine code. So a translator will normally convert your source code into a machine code. So normally we will be giving an input program, and that input program will be converted to an output program. So the purpose of translator is also to detect and report error during translation process. And there are different types of translator, namely compiler, interpreter, and assembler. In case of compiler, a compiler is a program which translates a program written in one language into an equivalent program in another language. So here, whenever we give a source program in one language like C, C++, or Java, that will be compiled using that particular compiler, language compiler, and a target program will be generated. And in between this translation process, some error messages will be given by the compiler if any occurs in the source statements. So the next one is interpreter. The interpreter will be used to producing the code directly instead of creating an intermediate code. So that's the difference between a compiler and an interpreter. Normally, your compiler will be converting your whole program into a machine level language, and in case of your interpreter, line by line the statements will be executed, and one source statements will be converted directly to the machine code. So that is the advantage of the interpreter. And here the source code will be given to the front end, and there will be an analysis process, an intermediate code will be generated, and there will be a backend process which we call as a synthesis, and it will be generating an executable code. So example of interpreter is Java will be using an Java interpreter. So whenever your Java high level language is given to the Java compiler, it will be generating a bytecode, and the bytecode itself is enough for running a program in any kind of machines. That is the advantage of your Java, and Java compiler is normally called as an hybrid compiler. And the other kind of translator is called as an assembler. Normally assembler will be converting your assembly language code into a machine language code. So these three are called as the translators. So compiler automatically falls into the category of a translator. And there are a few good properties of any compiler. The compiler should be reliability. That means it should give consistent way of conversion of your source program to the machine language code, and it should be achieving faithfulness, and the speed of the compilation should be high, or at least average enough in order to convert the program in an easier method. And diagnostics. So in case of diagnostics, the compiler should be able to diagnose the errors when and where, and if any kind of logical error or an runtime error is occurring, it should be diagnosing is easier, and error should be handled by the compiler itself. If there is a runtime error or a syntax error, it should be handled by the compiler itself in order to indicating the error messages to the programmer. And the implementation and maintenance of the compiler should be good, and it should have a good human interface. These are the properties of any good compiler. So normally the parts of compilation is done in a phase by phase manner, and it will be divided into two parts, normally analysis and synthesis part. So in case of analysis part, the source program is broken up into constituent pieces, and it creates an intermediate representation. And the tool used for these analysis parts are structure editors, pretty printers, static checker, and an interpreter. And in case of synthesis part, after generating the intermediate code in the analysis part, the compiler has to construct the desired target program from the intermediate code representation. And this is the given structure of any modern compiler. So the modern compiler will be having various phases for this conversion. So normally the source code will be given to an lexical analysis phase, and the syntax analysis phase, then an semantic analyzer, then an intermediate code generation, and this is an intermediate code optimization, and then the target code generation and the target code optimization, which will be converted finally to one machine level code. So that means these are considered as the phases of compiler. So the first phase of the compiler is the lexical analyzer, where your source program is divided into tokens. It is called as tokens. So that tokens will be given to the syntax analyzer, which will be using a parser for checking whether the syntax is correct or not. Then that will be moved to one semantic analyzer, where the meaning of the statements is verified, and particularly type checking and type conversion is done on the semantic analyzer phase. And then an intermediate code generator will be generated normally. And finally, a code optimizer will be there, where these intermediate code representation will be in 3 address code, and the code optimizer will be eliminating the dead code or unwanted codes which is available after the intermediate code generation. So after the code optimization phase, finally the code generator will be generating the target code, and that is called as the target program as the output. So for all these phases, there should be a link between a symbol table manager and an error handler. So the error handler will be used in all the phases, where the kind of error, lexical error, will be indicated by the compiler during the lexical analyzer phase. Syntax error will be given by the syntax analyzer during the syntax analyzer phase. Likewise, all the phases will be reporting some errors during the compilation process. Apart from that, a symbol table manager is required in the compilation phases. The symbol table manager is used to store the variables which we are using in the source program. So that variables will be stored in the symbol table. So whenever required by the compiler during the compilation process, the symbol table will be taking up the variables in the symbol table, and it will be referencing in the all the other phases. That is the purpose of a symbol table. Thank you.